All right, 16.3, experimental probability. Again, probability of an event is just number of winners over total number. Now I'm going to show you compare experimental probability with theoretical probability. Experimental probability is what did happen. You do an experiment or you do a survey and it's past tense. And then theoretical probability is what should happen. It's the future. I mean, anyway, so like experimental probability, if you have experimental probability of 0, that means it never happened. Like I flip a coin 3 times and I get heads, heads, heads. The probability of getting tails would be 0, even though it's not. It's not impossible. Theoretical probability of 0 means it's impossible. In the future, it'll never happen. But experimental probability means it just, or it's impossible. It never will happen. But an experimental probability means it didn't happen. So if you just do an experiment or survey a small number of times, you might get an experimental probability of 0. That doesn't mean it's impossible. It just means it didn't happen ever. Now, an experimental probability of 100, that means it happened every time, like heads, heads, heads. That would be what's probability of heads, it'd be 100%. That doesn't mean you're always going to get heads on experimental probability. It means it happened every time during that survey or experiment. That's why it's important when you do a survey experiment that you have a big sample size. You do it a bunch of times. You have a big total so that you can have more confidence in your results. And then, so theoretical probability of 100%, like what's the probability of rolling a dice and getting less than 7? Well, that would be a certainty. It'll happen every time rolling one dice because all the numbers are 1, 2, 3, 4, 5, 6. They're all less than 7. Anyways, there's that. Okay, so number 3 here. What's the theoretical probability of rolling a 6? Well, that would just be 1 out of 6. So here they did this rolling the dice a bunch of times, and so they add up. It's nice to get a total that you can get to 100. So then it's easy to find the percents. So it's just like review. Here's my total. My total is 20. Well, that's just times 5. And so I can make these into percents nice and easy, as long as I'm asking what's the probability of just each of these individual things. Number 6, what's the probability of rolling a 3? Well, it's 25%. What's the probability of rolling a 6? Well, that's 5%. Now, if they said what's the probability of rolling a 3 or a 4, you can just add those and get, 45%, because or means either. Anyways, number 12, on that spinner, what's the probability of spinning yellow? Well, there's only one yellow space, so it's 1 out of 6. Number 15, what's the probability of not blue? Well, 2 of them are blue, so 4 of them are not blue. So it'd be 2/3 or 67%. Number 18, so this spinner here, I got a paper clip and I held it with my pen and I spun it 36 times, and I kept track of my results, and so I got 16 reds, I got 14 blues, and I got 6 yellows. And so then 16 out of 36 reduces to 8 out of 18, which is 4/9, which is okay, that's 44%. Now 6 out of 36, that's a 6, that's 17%. That's what I would expect. So yellow is what I expected. I didn't expect red and blue to be so close together. I mean, there's twice as many reds as blue. I would expect the probability to be about twice of the blue. But since I only did it 36 times, my results, are not what I expected. But that would be why, because my sample size is small. I mean, if I did it 6 million times, it would probably be 1 million. Anyways, it'd be twice as many of this as that. And then down here again, for 21, added those up to 20, and that's just times 5, and I can get my percents. Oh, so here what's probably red or blue. So red was 15 and blue was 30, so it'd be 45%. And then, so make a tree diagram, first, second, and third flip, and then list them all out, and here's my sample space. Number 27, not historical fiction. Well, if 37% of the class preferred historical fiction, then the complement would be to subtract from 100, so 63%. And then number 30 was a nice review question. This is just weasel, door number 1, just times 3 times 3, so n is 30. All right, hope you're doing good, buddy.